Remember that moment in A Trip to the Moon, when those filmmakers way back when blasted their capsule toward the stars?
Oh, yeah.
Okay, so maybe launching from a cannon wasn't exactly how we do it today, but you got to admit it captured the spirit of exploration. And it just goes to show this whole idea of us living on the moon. It's captivated us for ages.
It really has.
And the thing is, it might be closer than we think. We've got your notes right here in this article, Lunar Bases, Living on the Moon by 2030, a cosmic reality check.
Yeah.
Seems like you're really interested in what we can actually achieve by 2030.
Yeah, exactly.
What hurdles are in our way, and honestly,
Yeah.
why even go through the hassle of setting up camp on the moon? So should we just dive in?
Let's do it. It's a question that's been debated for years, driving research for decades now, really. And what's so fascinating is how much our understanding has evolved even since, since the last human walked on the moon back in 72.
It's kind of wild when you think about how long ago those Apollo missions were. I mean, for a lot of us, it feels like ancient history. But something tells me things haven't exactly been quiet up there on the lunar front while we've been down here. What's been going on?
Well, instead of sending people up, we've entered this whole new era of robotic explorers.
Oh, interesting.
Think of them like our scouts. They're up there gathering intel, paving the way for when we do send humans back. Missions like the Lunar Reconnaissance Orbiter, they've been mapping the lunar surface and in incredible detail. I mean, they're using instruments that analyze mineral composition, searching for resources like water ice. Wow.
And then you have China with their chain missions. They're hitting these amazing milestones, landing on the far side of the moon. That's huge.
Yeah.
I mean, the precision and ingenuity that takes, it's incredible.
Landing on the far side of the moon, that's a whole other level. It really highlights how far our technology has come.
Oh, absolutely. And we can't forget about India's Chandrayaan missions either. They've given us vital insights into lunar water deposits, which, as you can imagine, would be essential for humans to stay there long term. Like Chandrayaan-1. It carried an instrument that actually confirmed the presence of water molecules on the surface.
So it's more than just figuring out if there's water. It's about where it is, how accessible it is, all the things that determine if we can actually use it. That's where this detailed data becomes so crucial. Precisely. Every mission, every piece of data, it all feeds into this larger goal of building a sustainable lunar presence.
So it's like we're putting together this giant lunar puzzle, one mission at a time. And speaking of missions, there are quite a few launching soon, right? What's on the horizon?
Oh, tons to be excited about. This year, NASA's Artemis I is set for a lunar flyby. Now, it's uncrewed, just a test flight, but still a huge step.
Right.
And next year, things get really interesting. Japan's SLIM mission, it's aiming to show just how accurately we can land on the moon, which is critical for future lunar outposts.
But we're talking like touching down with pinpoint accuracy.
Yeah.
Makes those Apollo landings look huge by comparison. That's impressive.
Exactly. And then there's India, again, with their Chandrayaan-3 mission. They're aiming for a soft landing on the surface. If they succeed, they'll join a very small group of nations who've pulled that off.
Wow. It's a really exciting time to be following lunar exploration, I have to say. Seems like we've got some real momentum going. But before we get too caught up in all the excitement, we have to address the elephant in the space capsule, let's say.
Right.
Living on the moon is no walk in the park. Our article doesn't sugarcoat that at all.
It's true. It may look all tranquil and serene from down here, but the moon, it's a pretty harsh environment.
I'm starting to think harsh might be putting it mildly.
You might be right about that. Yeah, harsh might be an understatement. I mean, for starters, there's no atmosphere to speak of, which means, well, no protection. No protection from the sun's radiation. No protection from micrometeoroids, those tiny little space rocks that are constantly bombarding the surface.
Oh, right. I haven't even thought about those.
And the temperatures, they swing wildly. I'm talking extreme heat during the lunar day, extreme cold during the lunar night, and each one lasts about 14 Earth days.
14 Earth days. Oh, wow. That's a long time to endure those conditions.
It is. It makes things really tricky. And resources, they're scarce. We can't just ship everything from Earth, though we'll have to initially. But it's expensive. It's logistically, it's a nightmare. That's why there's this big push for what we call in situ resource utilization, ISRU.
ISRU, right? It's like, when in Rome, use what's already there. Or I guess when on the moon.
Exactly. Use what the moon gives you. And what it gives you is, a lot of regolith. That lunar dust we talked about. Turns out it might be the building block of the future.
Wait, hold on. Are we talking about using that moon dust to, build stuff?
Precisely. We're already working on tech that can bind that regolith, turn it into a substance kind of like concrete. The European Space Agency, they've even got this moon village concept. The buildings would be modular, 3D printed, and made from that regolith-based material.
So instead of hauling stuff all the way from Earth, we're talking about using what's already there. Way more sustainable.
Exactly. Less waste, less reliance on Earth, and it gives you more flexibility in how you design things.
Okay, so I'm getting a better picture of this moon village now. 3D printed, modular buildings made from local materials. But what about the stuff we need to survive? Air, water, all that. Can't exactly just run to the store for that.
You're getting at another crucial thing, self-sufficiency. We need systems that can recycle and regenerate essential resources, closed-loop life support systems.
Like what they're using on the International Space
You
Station.
got it. The ISS is a great testing ground. But of course, adapting it for the moon, it comes with its own challenges. Everything has to be, seriously robust, super reliable. Because repairs on the moon, let's just say, it's not as easy as sending a repair guy up there.
It's amazing when you think about the technology to make sure it all works perfectly in such a demanding environment. Okay, so we've got our 3D printed habitat. We've got our life support up and running. But something tells me we're going to need a pretty powerful way to keep it all powered, especially with those long lunar nights.
You're absolutely right. Power generation is huge, especially with those 2-week nights we talked about.
Yeah, relying solely on solar power with that much darkness, that's got to be a challenge.
It is. So we need to think about how to store energy during those long nights. We're talking advanced batteries, fuel cells, and for a more long-term solution, potentially even nuclear fission reactors.
Nuclear reactors on the moon. That sounds pretty sci-fi, even for this conversation.
I know, right? But it's not as far-fetched as it sounds. We're not talking about massive reactors like we have here. Think smaller, more compact, designed specifically for space. In fact, NASA's Kilopower project. They're developing these super innovative portable reactor units. They could be a game changer for lunar outposts.
Portable nuclear reactors. It's mind-blowing to think about how we're adapting all this technology. But hey, if it means having a reliable source of power, it makes sense to explore all the options.
Exactly. And it all ties back to ISRU, using what's already there. Because guess what else the moon has in abundance that could change everything about power generation?
Okay, now you've got me curious. What other lunar treasures are we talking about?
Helium-3.
Helium-3. Now, why does that sound familiar? Isn't that like the stuff in balloons? What's so special about it?
Well, not quite the same helium you're thinking of. Helium-3, it's a rare isotope of helium, and it's incredibly rare here on Earth. But on the moon, it's abundant. And here's the kicker. It has the potential to be used as fuel for nuclear fusion.
Hold on. Are we talking about clean, practically limitless energy? Like the holy grail of energy sources?
That's the idea. We're talking about an energy source so powerful, even a small amount of this helium-3 could power a whole city for years. Of course, fusion technology, it's still in its early stages, even here on Earth. But if we can figure it out, that helium-3 from the moon, it could be incredibly valuable.
That's amazing. Lunar bases powered by fusion energy does sound a little too good to be true. But let's be real, we're not going to be filling our cars with helium-3 anytime soon, are we?
Probably not. There's a lot of work to do before fusion is a reality. But the potential, it's there. And that's pretty exciting.
It really makes you think. Space exploration, it's not just about what we find out there. It's about how it inspires us to do things differently here on Earth, pushing the boundaries of science and technology, making things better for everyone. Okay, I get the potential benefits, but with all this talk of fusion power and moon dust construction, it's easy to get a little carried away. Let's take a step back. Why go through all this trouble in the first place? What are the real, tangible benefits of setting up a permanent base on the moon? It's easy to get caught up in all the technology and the how of it all, but at the end of the day, it comes down to what we gain from it as a species.
I agree. It's about understanding the universe better, our place in it, uncovering new scientific discoveries, pushing the limits of what we can do as humans. The moon gives us this unique opportunity for research that we just can't replicate here on Earth.
So give me an example. What kind of research are we talking about? What are those lunar experiments that get scientists so excited?
Well, imagine this. Astronomical observations without that pesky Earth atmosphere messing things up.
Ah, I see where you're going with this.
We could build telescopes on the moon. Telescopes that could see deeper into space than ever before. We could unlock secrets about how the universe began, how galaxies form.
It's like having the best seats in the house for a show that's been going on for billions of years.
That's a great way to put it. And it's not just about looking out at the universe. We can study the moon itself, its geology, what it's made of, its history. That can tell us how our own solar system came to be. The moon holds clues to our planetary past, unlocking those secrets. That could change everything about how we understand how planets form and change over time.
So it's like a time capsule, this pristine record of events from billions of years ago.
Yeah.
And because the moon's environment is pretty much untouched, it's a goldmine of data.
Exactly. And we can't forget about the moon's low gravity. That
Yeah.
opens up research opportunities we just don't have here. Imagine the experiments we could do. It could lead to breakthroughs in materials, science, medicine, understanding how gravity affects living things.
It's like this giant laboratory where the rules are a little different so we can test the
Oh,
limits of what we know.
exactly. And those findings could have a huge impact on so many fields. And beyond the science, there's the potential economic benefits. We've talked about helium-3, but there's also the possibility of mining other resources. Rare earth elements, for example. Those are essential for electronics.
So the moon could be a source of valuable resources that we could use in space or even bring back to Earth.
Exactly. It's still early days for that, but the potential is there. And then there's space tourism. It's just starting, but it could become a huge industry in the future.
Lunar vacations, imagine that. The ultimate adventure trip. But beyond the economic and scientific benefits, there's something else that I find really compelling. It's the idea of the moon as a stepping stone, a testing ground for even bolder missions.
You're talking about Mars.
Exactly. Everything we developed for living on the moon, life support, power generation, shielding from radiation, all of that helps us prepare for sending humans to Mars. It's like a practice run before the big game.
It's about building on our successes, learning from our mistakes, and using that knowledge to push further. The moon is a crucial step on that journey. It's where we test the technologies and strategies that will one day allow us to become a multiplanetary species.
It's humbling and incredibly inspiring. A small step on the moon, a giant leap for mankind, right?
Yeah,
It's amazing how relevant that still is.
it really is. And it highlights how important it is that we work together, pooling our resources, sharing our expertise to achieve this common goal.
Okay, so we've talked about the what and the why of living on the moon. But what about the when? That 2030 deadline seems awfully close, especially since we haven't even gone back yet. Are we on track? Or is that a little too optimistic?
It's ambitious, for sure. But look at the progress we're making, the technology, the global interest in lunar exploration. It's not impossible. Think of it as a series of steps. Artemis the first launching this year, Artemis the second with a crew orbiting the moon in 2024. And if everything goes to plan, Artemis the third will put humans back on the surface by 2025.
So 2025 is shaping up to be a huge year for lunar exploration. But what happens after that initial excitement? What are the next steps in making a more permanent presence?
The years after that, 2026 to 2028, will likely be about building the basics, habitats, power sources, communication systems, and of course, making sure everything's properly shielded from radiation and those micrometeoroids. It's like, I don't know, setting up a really, really remote research outpost, except instead of Antarctica, it's the moon.
Talk about off-grid living. So by 2030, what's the ultimate goal?
A sustainable presence on the moon, a small outpost, maybe even a village, a place for long-term research, exploration, and even potentially using the resources there.
A lunar village. I like the sound of that.
Yeah.
But even with the best plans, things can go wrong. What are the biggest challenges we face in meeting this 2030 goal?
You're right, there are always unexpected challenges, technological hurdles, funding issues, even something unpredictable, like a solar flare. Space exploration is risky, and setbacks are just part of the process.
But those setbacks often force us to innovate, come up with even better solutions, right?
Exactly. And it's not just about overcoming challenges, it's about doing it responsibly. As we venture out, we have a responsibility to minimize our impact on the lunar environment, make sure it stays this pristine place for future generations.
Finding that balance between exploration and preservation. Because we're not just visiting the moon, we're becoming caretakers of its future.
Yeah.
This has been an incredible journey, even if it was just a simulated one here in the studio. It's mind-blowing to think that we're at the edge of such a pivotal moment in human history.
It really is an amazing time to be alive, wouldn't you say? The next decade is going to be full of incredible discoveries as we push the boundaries of exploration and head further into space than we ever have before. Who knows what we'll find?
Who knows indeed. That's all the time we have for today's Deep Dives. We'll be back next week to delve into another fascinating topic. Until then, keep looking up.